Hello. Now we are going to start chords and arcs of circles. So today, if you want to follow along, you can take the Google Doc and we're going to go over some definitions. Most of these you already know, they're just a review. There are some theorems and converse of theorems, but they're very self-explanatory and they have diagrams to follow along with that. All right, so let's get started. Over here we have the chords and arcs of chords, and I have some diagrams to show you. Here is a diagram. We have a circle. Here is the radius. The radius, any segment with endpoints that are on the center and a point on the circle is the radius. We have the diameter. A diameter is a chord that passes through the center, okay, and goes from one end of the circle to the other end of the circle. We know what a diameter is. This right here, this given point is called the center of the circle, and that names the circle. If we know what that point is, let's say that's point O, then this would be circle O. And any segment with endpoints that are on a circle is called a chord. Right here, the endpoints are on the circle. It's not a diameter because it doesn't go through the center, so this is just called a chord. We have an example in example 1. Name the circle. Right here, here's the center. It's an O, so this is circle O. Name a radius. We really have 3 of them, OB, OE, and OC. Name a chord. The most obvious one is this one up here, AB. And name the diameter, DE. You could also say ED, but normally we put these things in alphabetical order. I would like for you to do the same thing over here with this circle. What is the name of the circle? Give me a radius. 1 is fine. Okay, a chord and a diameter. I can see also that P and Q, really those are just points. They don't have anything to do with this circle. Since the diameter is composed of 2 radii, okay, then the diameter is equal to 2 times the radius, and the radius is half the diameter, or the D over 2. At the bottom part of the page, we have all the theorems, okay? We have the theorems and the converse of the theorems. They're pretty easy. Within a circle or congruent circles, chords that are equidistant from the center or the centers are congruent. What this is saying, if these, in this circle, if these are the same distance away, which they are, we can see these little marks means that these are the exact same. They're both perpendicular. These chords are the same. The converse says if the chords are the exact same, okay, and they're equidistant from the center, right? So if the chords are the same, they're the same length from the center. If the chords are the same length from the center, then the distance is the same. That means a theorem and then the converse. Theorem 2, within a circle or congruent circles, the congruent central angles have congruent arcs. So if these angles are the same, then these arcs are the same. If this angle right here and this angle is the exact same, then arc AB is the same as arc CD. And the converse is the opposite. If the arcs are the same, then the angles are the same. Within a congruent circles, congruent central angles have congruent chords. Okay? So if these right here, if this right here, AB, okay, if AO is going to be congruent to this right here, AOB is going to be congruent to COD, then AB is congruent to CD. Then the chords are the same. And then the converse. And then the last one on this page, within the circle or congruent circles, congruent chords have congruent arcs. Okay? So if AB is congruent to CD, then these arcs that are outside are also congruent. And then the converse, if the arcs are congruent, then the chords are congruent. All right, let's go on to page 2. I have it on the back side. Okay, the following chords are equidistant from the center of the circle. So both these chords are, I'm going to do A and I'm going to have you do B. All right? What is the length of RS? So I'm asked for the length of this chord right here. Now, just looking at this diagram, I can see a couple of things. All right, this measurement from the center to the chord is 9 units. From the center to the chord of this one over here, PR is 9 units. Both of these are right angles, okay? And over here, PQ is 12.5. I can see that PQ and QR are the exact same. These little marks means that they're exact same. So if this is 12.5, this is 12.5. Well, our theorem says that these are also going to be congruent. Okay, so if this is 12.5 and this is 12.5, I know that RS is equal to, okay, 12.5 plus the 12.5. So it is going to be 25 units. Okay, since this is 12.5, then this one right here is going to be 12.5, and so is this one over here. So the whole thing is going to be, RS is going to be 25 units. I'm going to ask you to do B. And down here, we have 3 more theorems. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, so if AB is a diameter, AB and CD are perpendicular right here, okay, then these right here are going to be congruent. And these arcs are going to be congruent. That's what this says. Then these are going to be congruent from C, E, and ED. These are going to be congruent, and the arcs outside are going to be congruent. In a circle, if the diameter bisects a chord that is not a diameter, then it's perpendicular to the chord. It's really taking the first theorem that we have up here, and saying the opposite of it, okay? So if we know that this is the diameter and it bisects it, okay, then this is going to be a right angle, all right, or perpendicular. And in a circle, the perpendicular bisector of a chord contains the center of the circle. So if this chord and this chord, if they're perpendicular, then this one right here is going to go through the center of the circle. It is a diameter. Okay? I'm going to ask you to do example 3, example 4, and then you try. They are very easy. You know that I can be found online if you have any questions, okay? But I'm going to tell you all 4 of these, you're going to use the Pythagorean theorem, okay? I'm going to give you an example right here. OD is 15 units, so I know that this right here is 15 units. CD is 24 units. Well, in our theorem up here, we've seen that this is going to bisect it. If it's perpendicular, okay, and it is going to bisect it, this chord. So if this is 24, we have 12 on this side and 12 on this side. You can use your Pythagorean theorem and find the value of x. You can use the Pythagorean theorem in the way we've done on all of these others down here. Okay? I hope that you have a great day, and I hope that you contact me if you have any questions. Goodbye.